Welcome to the Al-Attiyah Foundation's latest podcast of the current series, where we seek to address the urgent energy topics of today by hearing the opinions and insights from our invited experts. The Al-Attiyah Foundation is an independent think tank aiming to provide robust and practical knowledge on global sustainable development topics and to communicate these for the benefit of the Foundation's members and community. Human society is seeking solutions to our energy-devouring paradigm, and our hopes currently lay at the roots of green growth. However, finding a balance between a high energy substitute to carbon that can also mollify and solve environmental problems has been an issue. There's one budding option, though, coming into view, which could build new industries and substitutes for carbon without some of the negative consequences, and that's hydrogen. David leads EforTech strategic advisory and consultation work on fuel cells and hydrogen globally. Recognized as one of the leading experts in the area, David is also a visiting professor at Imperial College London's Centre for Environmental Policy. He leads and conducts projects from research to strategy in different industry sectors for governments, corporations, and investors worldwide. Good afternoon, David, and welcome to an Al-Attiyah Foundation activity.
Thank you, Noeed. It's a real pleasure to be able to join you.
Great. Let's start off, then kick things off with your vision of the future of hydrogen. I touched upon it there. We recognize the climate change arguments, the need for an energy transition period. Is a hydrogen-based economy really inevitable, do you think, or are there opportunities to develop this in new industries based on hydrogen that we haven't really thought of, potential uses that we haven't even thought of yet?
I think we've thought of most of the uses. I mean, my view is that having a greater proportion of hydrogen in the energy economy is inevitable. I think there is a question about exactly what proportion that is, but it will be substantial. It will be tens of percent of energy from now until 2050 at the very least. And it's really interesting that it permeates into all sorts of different areas. So it can help us with decarbonising heat. It can help us with decarbonising industry, transport, you already mentioned, the overlap with fuel cells. So there are lots of opportunities. Some of them we probably haven't thought of, but certainly the big picture we have.
And one of the key issues you find with nascent technologies like this is the adoption of hydrogen as a generation fuel is very much dependent on scale, how many people are doing it. There may be niche opportunities, but also large-scale uses. I mean, they're only going to come about with large-scale production, aren't they? How do you view both those big and small opportunities in the sector at the moment?
Yeah, it's a really interesting question because we're now at a position where hydrogen as an industrial chemical has been used for 100, 150 years. It's very well understood. It's used in refining, it's used in metallurgy, it's used in all sorts of areas. So we already have scale to an extent. What we're talking about now is a transition to energy use, and that's very different because it requires different infrastructures, it requires different people to be involved. The general public will have a lot more access, and understanding is required. And you're right that on one side we need scale, and the best way to move forward with that seems to be actually to engage the industrial users who already use hydrogen and to get them to move from what we call brown hydrogen or grey hydrogen, which is produced from fossil fuels, which has significant carbon emissions, to green hydrogen or to blue hydrogen. And we'll talk about those colours. Those are basically low carbon forms of hydrogen. And that gives immediate scale for the demand side, and it means we can ramp up the industry which produces it. The other really interesting thing is that hydrogen offers an opportunity for decentralized energy, and it offers the opportunity to be combined with batteries and with electricity and with local renewables to do things at small scale and, as you say, at niche, and to be able to solve local problems with locally available resources. So there are two logically linked but nevertheless slightly independent development pathways that need to be followed, I think.
And you touched upon ordinary people there. Is there any evidence to suggest that ordinary people are aware of hydrogen, are receptive to hydrogen, want hydrogen in their lives?
Increasingly, yes. I mean, in some countries, there's already been a lot of work on hydrogen. So Japan There are 350,000 fuel cells in people's apartments, which produce heat and power and hot water. In other countries, so California has about 10,000 hydrogen cars on the road. So in some places, there's a lot of awareness already. And by and large, the general public is increasingly well informed and increasingly positive about the opportunities for hydrogen, sees it as a way of enabling a better air quality, lower carbon emissions, new technologies, new jobs, new economies. So by and large, there is an increasing understanding. There is, of course, a long way to go in terms of education and rollout and exposure to actual technologies.
And one key factor helping with that will be the cost, both for consumers, also for industrial use as well. If you remember, towards the end of the 20th century, the start of this century, we really saw the cost of solar and wind power generation fall rapidly, and people started using it much more. So at some time, do you see green hydrogen production to become economical like other forms of green power? And where will the competition be then for hydrogen? Will it be from, say, batteries for small scale users?
Yes, I think that there are one of the reasons we're very interested in hydrogen now, and one of the reasons why it's become such a relevant topic, and industries are really getting involved and governments getting involved, is because of the reduced cost of solar and wind. So that actually enables the production of low-cost hydrogen. There are still one or two sort of industrialization steps required, which are scaling up, for example, electrolyzers and the electrolyzer industry, and putting in place supply chains for large scale, because it is scale that brings cost down. But there will definitely be low cost green hydrogen which is available. And there is a very clear pathway to that. A lot of analysis has been done. There is a strong belief both in industry and in politics that this can replace a whole range of different things that we use at the moment. But it will also, I think, there will be a cross-fertilization. So in some cases, the competition will be batteries. In some cases, this will work with batteries. So for a small passenger vehicle in an urban environment, a battery makes a lot of sense. For long distance, heavy duty trucking, it's difficult to achieve that with a battery because they tend to weigh a lot. Hydrogen will be the opportunity, but actually probably the vehicle will have a small battery and a big hydrogen tank. So it all works together.
And let's talk a bit about what you do then. You lead the consultancy side of a company called EforTech. Tell us a bit about what that does related to hydrogen.
Yes, of course. So we're a specialist energy consultancy. We work on the energy transition. We're about 30 people based in London, and I'm based in Switzerland. And we look at all sorts of different forms of energy. I lead what we do on hydrogen and on fuel cells. And at the moment, we're very, very busy. We're answering questions about new technologies and how they will scale up and whether there are opportunities in the market. We're answering questions from big corporations about where they fit in the coming energy transition and what hydrogen does for them, whether it's a threat or an opportunity or part of both. We do a lot of policy work with governments and with multilaterals such as the World Bank and others on how you enable the right environment and framework to allow companies to put private capital into this or to put industrial capital into this and build up. And we work a lot with investors as well. So people looking for the next big thing or people looking for project finance or other areas. So it's across the whole scope of anything that could be related to hydrogen energy, really. It's very, very interesting.
And moving back to hydrogen then, what sorts of countries are leading when it comes globally to hydrogen? Tell us a bit about that, particularly looking at the Middle East and Qatar as well.
Yes, so I'll come to the Middle East in a second. I mean, the traditional leaders are countries like Japan. Japan has had a very long-term hydrogen program, has a lot of industrial players who are very well placed to make production equipment, to make fuel cells. Toyota is a leader. Korea, I would say, is a fast follower, but they've been very, very aggressive about a lot of technology development and about implementing hydrogen policies. Germany, so this is the usual suspects, I guess. Germany has a very well thought through hydrogen plan and a strategy which was announced relatively recently. California is very much leading in terms of North American opportunities, and then we see others scattered around. So Australia has come recently onto the circuit, as it were, to say we would be very interested in not only deploying hydrogen, but also producing it from renewables and exporting it. And I think that's where the Middle East plays particularly strongly. So we've seen other Gulf states and other regional states starting to think about hydrogen strategies and starting to think about ways to participate. Big announcement from Saudi Arabia, from NEOM, about one of the largest green hydrogen producing facilities to go to ammonia production. And of course, Qatar is very well placed for two things, I think. One is green hydrogen. You know, it's a large country with a lot of insulation available, and could certainly put in place something similar in terms of producing and exporting green hydrogen, but also from the natural gas resources that already exist. I mentioned blue hydrogen. It all sounds very strange. The hydrogen doesn't have a color. What people mean when they say blue hydrogen is hydrogen that is produced from natural gas, but when the carbon is taken out, CO2 is sequestered or used in some other way. And that is not quite as clean as green hydrogen, but it's very close. And clearly there's an opportunity also there for Qatar potentially to be shipping hydrogen in some form as well.
Great. And in terms of fuel cells, you've touched upon them, and also transportation, something that's going to impact users all around the world. Are fuel cells one of the answers for transport? And where do you see the target area? Is it going to be heavy transport, for example? Will it be rail travel, haulage areas, essentially, where lines aren't electrified yet? Is that where hydrogen could be particularly useful?
Certainly, that's a sweet spot at the moment. I think fuel cells are absolutely part of the armory when it comes to decarbonising transport and particularly improving air quality. And that's where we see a lot of policy drivers at the moment. We see cities banning diesel engines, talking about zero-emission buses and zero-emission fleets in city centres to improve air quality as much as anything. And fuel cells have advantages over batteries. They also have disadvantages. But basically, where they really play well, as you say, is in heavy-duty transport. So if you're looking to run, let's say, a 40-ton truck, you probably need something between 5 to 8 tons of batteries. That's an issue, and it's quite difficult to recharge that amount of battery in a short period of time. You need very big power consumption. A fuel cell, on the other hand, with hydrogen tanks on board the vehicle, in principle, at least, you can refuel that in 15 to 20 minutes. There are protocols being developed to do that. There are companies who are building trucks like Hyundai, like Iveco, and others. And you can then run for multiple hundred kilometers on a single tank without compromising the payload. And that translates equally well into things like railways. So there are already hydrogen trains running in Germany. There are more trains that have been announced in Austria, in California, in the UK, in France, in the Netherlands. So that's really a growing area. And then even in shipping. So decarbonising shipping is a very big topic. The International Maritime Organization is talking about emission standards. Fuel changes take a long time to implement in heavy shipping. But fuel cells and hydrogen, even in internal combustion engines, so in big engines, could equally be very, very clean. And so that is seen as another opportunity. All of these things fit together. We can't, I think, be too dogmatic about one technology over another until we have tried them, shown them, done the analysis, done the infrastructure development. And it's very clear that batteries and fuel cells will continue to coexist for a long time to come in the transport sector.
And if there was a need for transportation use to be ramped up, production, infrastructure, can that be ramped up significantly as well? Is that even possible at this stage?
All transitions take time. So even if you just look at how long a car stays in the typical fleet, that could be 10, 12 years. So just the fact that people need to buy new cars means that it will take, even if you had 100% new cars being fuel cells now, it would take 12 years for the whole fleet to be fuel cell cars, and that's the most ludicrously fast opportunity. So yes, it needs ramping up, it needs rolling out. What is happening at the moment is that companies like Toyota and Hyundai are moving from a few hundred vehicles a month to tens of thousands of vehicles a year. That's still quite a small number. The supply chain is also growing alongside of that. So we see tier one companies, as they are called in the automotive jargon, companies like Bosch and Michelin, who supply the automotive car builders, the OEMs. They are also getting engaged. They are building factories to build fuel cells. And at the same time, we're seeing hydrogen refueling stations being put in place, mainly for passenger vehicles, for cars. So Japan has about 100 fueling stations. Germany has about 80. California has, I think, around 40. And they are building out more and more so that people don't suffer from sort of the equivalent of range anxiety that you get with battery vehicles, that they're able to believe that they can take their fuel cell car and refuel it wherever they need to. All of this takes time. All of it will become more cost effective as we go on. But at the moment, I'm not so concerned about that. I won't say concerned. I think it's more important to think about doing this in an effective manner. If you put one fueling station in each country, then of course you have no network. That's not very useful. You need to think about doing this in a focused cluster sort of fashion where you get scale economies, you get interaction between different use cases, you get some momentum which is building.
And just to broaden that out then, what do you think are the most important things for a shift towards a hydrogen economy? Would it be things like better technology? Would it be taxing carbon and carbon capture, for example, or just really the realization, the stick, if you like, that climate change has to be tackled and that this is one of the few realistic options to reduce our CO2 emissions?
I mean, that is the fundamental driver at the moment. There are four big picture drivers for hydrogen to be introduced, and they're the reason that different governments and different companies are following them. Front and center is greenhouse gas reduction. It's very hard to decarbonize some industries using electricity. Hydrogen gives us an opportunity to do that. It has to be part of the solution. There's an air quality benefit, which I mentioned, particularly in cities. Then there are two other things which are of interest. One is building and creating economic value and jobs. And certainly countries like Japan, strong automotive industry, very much want to be part of that going forward. So looking to create jobs. China is also looking at developing the fuel cell and hydrogen industry, partly for economic benefit. And the other is energy security. So that's another thing which is a big picture geopolitical, but also a small picture decentralized energy solutions opportunity. So those are the four reasons. In terms of how you actually go about it, it's very important to put in place a set of policy measures which are coherent. Some of that will be around things like carbon tax. It's going to be important not only to have some cost or value attributed to carbon, but also to make that uniform so that we have, for example, cross-border taxation of carbon so that you can't simply offshore your emissions. That'll be important. But if you do the calculations, you need actually very high taxes on carbon to make hydrogen economic right now. What's important at the moment are more specific stimulus packages or particular areas. So the European Green Deal, there is a lot of potentially post-COVID recovery stimulus, which will go towards green energy. Some of that will specifically go towards hydrogen. It will support technology development to some extent. But to be completely honest, we have most of the technology. It's good enough. We can deploy it now. And so it's more important to support scale up. It's important to support early projects. It's important to make sure that regulations are not getting in the way, because that's the other curious thing. It's not necessarily about pushing hydrogen. It's also about making sure that if people want to do hydrogen, there isn't a legacy regulation which was designed for fossil fuels or designed for a different market structure, which actually stops you doing it. And a particular example, slightly strange one perhaps, is you're not allowed to mix hydrogen into a natural gas pipeline in the UK, even though you can in Germany or in the Netherlands or in some other places, because nobody ever thought you'd need to do it. So the law says you can't. But actually, it's not a problem technically. It's just a legacy regulation which needs to be changed. So there are lots of things that need to happen, both on the sort of positive support side and on taking barriers out of the way.
Absolutely, and that's brought me on perfectly into the next thing I wanted to talk about, which is time to get a bit geeky, really. Let's talk about the different colors, which you touched upon towards the start of this podcast. We've generally talked so far about the use of green hydrogen, but there's a lot of hydrogen used already, particularly industrially, the increased use of blue or brown hydrogen. Is that a way to try and get hydrogen more widely used, do you think? Just talk us through the different types of what those things mean, blue, brown, and green, and how they can be used, for example, to encourage the widespread use of green hydrogen.
Sure. So I'll start from the darker end. So brown or sometimes grey hydrogen is hydrogen which is produced from fossil fuels, usually natural gas, sometimes even coal in China, and there is no carbon sequestration. So there are big emissions from that. It's in big picture terms not a good thing. It contributes to global warming, climate change. Then there's blue hydrogen, where you produce from a fossil fuel, but you do sequester the carbon or use it in some other way. So that has very significant emissions reductions potential and is very much seen as part of the solution going forward, at least in the transition period. Then there's the purest option, which is green hydrogen. And I think there is general consensus that we have to get to green, but that in the near term, we don't want to constrain too much in terms of ideology. And therefore, if we're going to move as fast as we want to, we probably need both green and blue. And then there's yellow, which you didn't mention, which is sometimes used, which is nuclear hydrogen. So producing again without carbon, but of course there are other discussions around how the nuclear industry needs to participate in any energy future. So that's why that's differentiated from green.
Great. And just to deviate a bit here, this is something I wanted to pick your brains around as an expert in the field. We've recently seen plans to develop hydrogen-powered aeroplanes. Is that the ultimate challenge for hydrogen, do you think, or is it just a pipe dream?
No, it's not a pipe dream at all. And if you see some of the announcements, they're very real. And Airbus in particular recently has been very specific about the opportunities. It's important to note that it is probably one of the most challenging areas because the amount of energy you need to contain on board an aeroplane in order to get a good distance and the amount of thrust you need to get out of an engine is very, very dependent on the fuel, and kerosene is a particularly good fuel for that. So hydrogen offers definite opportunity for sort of mid-range aviation, short and mid-range aviation. I think it's very clearly been shown that that's possible. I think for very long range that does become more complicated, and it will take a lot of time. There is also a complexity which arises again from the regulatory structure. So most planes flying between countries and most of the fueling agreements are actually bilateral between countries. And so in order to implement hydrogen planes, you'd need to have a whole number of agreements between countries about the fact that you could fuel with hydrogen and fly to another place and then fly back again. And there are lots of things that need to be done in order to put that in place. But I think we will see it coming. And as people start to believe more in the opportunity, there will be more rapid technology development. So there's some really, if you want to get geeky, we could get really geeky. There's some really interesting new engine designs for using hydrogen and actually even for using other hydrogen derivatives like ammonia in order to propel aircraft and other craft as fast and as far and as high as we will need to do so in the future.
Absolutely, and it's interesting you mentioned the role of regulation there, even with aviation. It just highlights how important a role governments and multilateral institutions have to play here. We've covered quite a lot then. I want to get to the crux of the matter. To progress the hydrogen economy then, let's just summarize. What would you say are the next essential steps that we need to do that?
I think a lot of them are kind of being taken. So we need the willingness and the realization that this is going to be something important. And I think there's no doubt that we've already seen that. We almost see a hydrogen strategy or a hydrogen roadmap appearing every week. Most recent, I think the US hydrogen roadmap a couple of days ago was published. So they're coming thick and fast. And there is a fairly bipartisan consensus. This hydrogen is not affiliated with any political party or any belief. It's generally viewed as a good thing, whether you see it from an environmental perspective or a jobs perspective or whatever perspective. So I think it has a lot of buy-in. So that's essential context. Then, of course, you need to put in place measures to start to support the nascent hydrogen economy. And again, that's happening in some places. For me, it's most important initially to get big projects on the ground. So as large as possible, as quickly as possible, because that does two things. One is it shows that it's real, so that you can point to something and say, hey, it does work, we're doing it, there's a business plan, it makes this product, there's no problem. The second is it encourages investment, it encourages development, it encourages the supply chain to really get engaged and to scale up and to bring those costs down. So those big projects are important. The other thing is, I guess, socialization almost. I mean, sort of what we're doing here today and what many other people are doing is introducing the concept of hydrogen, explaining some of its complexities, because we can't just say this is a panacea, this is, you know, a universal cure-all. There are things we need to put in place, education, we need to make sure we have the right standards and safety mechanisms and all of those things, so that we don't have an accident that is significantly detrimental, or so that we don't arouse suspicions, transitions that have gone on in the past with, you know, genetic modification and with all sorts of other things. There is inevitable there are questions that need to be answered and need to be answered honestly. So I think, you know, that's another pillar, is that sort of education and the frameworks for making sure that it is safe and it is clean.
Yeah, and transparency in today's world is something that's really something that's part and parcel of life in the business world. I think far more so than it was, say, several decades ago. And we could continue talking about this for a long, long time, but I think we'll have to leave our interview here, David. Thank you for your expert analysis and, of course, your time. We look forward to hearing from you again on the Al-Attiyah podcast, hopefully where we can talk more about hydrogen.
Very happy to be with you and look forward to the next conversation, as you say. Thank you very much.
Perfect. Thanks again, David. As we've heard, some very exciting developments in hydrogen energy and plenty of opportunities to build upon as well within new industries, while also helping, of course, to save the planet. A huge thank you for our listeners as well for tuning in. As always, watch this space for the next Al-Attiyah podcast in the series. I'm Naweed Jabbarkil. Goodbye.